In this section of the course, I would like to put some few practical examples in front of you where you will basically understand the full course that we already covered with the practicals. And these questions are usually an interview questions that I encountered myself, and I would like to place the answers here in front of you along with the practical examples that were given to me. So the first question is, what is BGP and why it is essential for internet routing? Now, the practical example for this question is, imagine you work for an ISP that connects to several upstream providers, provider A, B, and C. Your network uses BGP to exchange routing information with these providers. If provider A experiences a failure, BGP automatically recalculates the best path via provider B or C, ensuring continuous internet connectivity for your customers. Of course, if you are an ISP, you don't want your customers' access to go down, and this is the best way. I mean, you need to have the options where your router will basically direct traffic to the best path, right? So we will come to that, but here's the answer. BGP, Border Gateway Protocol, is the core protocol that manages how packets are routed between different autonomous systems on the internet. It is essential because it enables networks like your ISP to dynamically choose the best efficient and reliable route among multiple paths. This ensures redundancy and resilience across the global internet. So I hope this is very clear. I mean, it's common sense at the same time, but this is one of the interview questions that I came across, and I don't know did they like the answer or not, but this is up to them. But this is a good response that you can provide. Now the next question is, what's the difference between eBGP and iBGP? So the practical example of this is, consider a multinational organization that operates its networks via different regions. Within one region, Autonomous System 100 is used. All routers communicate via iBGP to share internal route information. However, when Autonomous System 100 needs to exchange routes with an external partner, let's say AS200, eBGP is used. For eBGP sessions, routers typically use TTL1 and are directly connected, ensuring that route information is only exchanged between the intended AS boundaries. So the answer here is normal. I mean, we covered this in our course also. External BGP, when it comes to external BGP, we used for routing between different autonomous systems. We know that. It typically operates with TTL1 to ensure that only directly connected exchange routing information, and it prevents unintended propagation. So basically it typically operates with TTL1 to ensure that only directly connected peers exchange routing information, preventing unintended propagation. So this is how BGP works. If it takes a route from an iBGP, it will change the TTL to 1, and it will make sure, like, it's only exchanging routing information from the peers that are intended to take routes from. Now, when it comes to internal BGP, it is used within the same autonomous system. Unlike eBGP, iBGP doesn't change the TTL and usually requires full mesh. We have seen that in our example. Or it uses route reflectors. Because routes learn from one iBGP peer are not advertised to another by default. Now, in the beginning when I was learning about BGP and IBGP, and I would do this and I wouldn't know why the route did not propagate to the second router that was peering uh, using IBGP, and that we covered on the traffic flow of the course, how the routes are learned. You need full mesh, and you need to use route reflectors for the routers that are not directly connected. I hope that explains the questions, and let's move on. How does BGP select the best path for routing? This is very unique and important interview question, and this is the answer. So practical example would be, suppose your network has two potential paths to reach a destination. Prefix. Path A has a higher local preference but a longer AS path. Path B has a lower local preference but a shorter AS path. Despite path B having a shorter AS path, BGP will choose path A because the local preference is evaluated before the AS path length in the decision process. This reflects a network's operator intentional policy to prioritize certain routes over others. So this is your answer to select the best path. BGP path selection process involves multiple attributes in a specific order. So number one will be weight, Cisco specific. If the routers are all Cisco, its weight is the best way to select the best path. The router with the highest weight is preferred. The second one that comes in sequence is local preference. Routes with higher local preference are chosen. I think most of the ISPs, what I've seen, they use the local preference as a way to select the best path. And just be careful here. I mean, it comes with experience too when you're doing this, but local preferences is something where the ISP will always play with to make sure, like, I'm in Canada, so let's say you have a Bell circuit and a Rogers circuit coming in. So local preferences are used on the edge router to make sure like it chooses the best path. AS path length. Shorter AS path is preferred, obviously. Number 4 will be the origin type. IGP origin is preferred over eBGP or incomplete. And that's obvious. I mean, if there's an IGP path, it will select the IGP path before the EGP. And MED, lower MED values are favored. eBGP versus IBGP. So eBGP learned routes are preferred over IBGP if all else is equal. Okay. This is again, this is important. IGP metric to BGP next hop. Lower internal cost is chosen, obviously. And in the end, this is sequence ensures that routing decisions align with both performance and policy goals. But from this, I mean, I would like you to understand that as long as you know weight, local preference, and AS path length information, you can basically manipulate that and make sure that the route that you select is basically the best path. As long as you can always do the change, right? You can increase the weight, and that will be the best path. You can change the local preference, and that will be the best path, and leave everything else default, right? You can even prepend the AS path to make it longer, so it won't be the preferred path anymore. So these are the practical ways of doing the best path selection. Let's move on to the next question. I think this will be the last question here. What are BGP communities and how they can be utilized? How can they be utilized? Sorry, it's been a long day, so the practical example is, imagine you operate a network that serves various types of traffic. You want to steer certain traffic away from congested links during peak hours. By tagging those routes with a specific community value, you instruct the downstream routers or peers to lower the local preference for these routes. This community tagging makes it possible to influence routing decisions without needing to reconfigure each router individually. So basically, BGP communities are like shortcuts you do just so that things are get done quickly. So the answer here is BGP communities are optional, transitive attributes used to group routes and apply consistent routing policies. They allow operators to signal how routes should be treated. For instance, to influence route preference, implementing filtering, or control the advertisement of routes to peers. Using communities, you can modify routing behavior dynamically based on pre-agreed policies. I hope that makes it clear. I mean, this will make sense to someone who has a little bit more experience, more advanced experience in BGP. But usually, communities are a good way to influence your routes and also trigger a change to the neighboring routers based on those communities that you type into the route. I hope these four questions clarify some of the points. During the course, we did a lot of practical examples, and I hope those practical examples, along with these questions kept in mind, will make it simpler to learn BGP. And I hope this course have achieved its purpose, and I'm glad that you joined. And look at other courses that I have published. I hope you will like those ones as well. Thank you again, and I wish you good luck in this BGP world